Okay, so you guys are looking at a lot of these kind of word problems, and you're looking at your parent function for exponents, and you're just trying to really fill in some of these pieces. Now, you saw the word decline here by approximately 3% each month. So when you're working with your b, that's usually 1 minus the 0.03, so you're dealing with a 0.97 as a decline. Now last year's magazine had about at the end of August, so they're talking about at the end here, right? End of August, where they had an amount of about 364,000. And to the nearest, about how many subscribers did the magazine have at the start of January last year? So I'm going to go back in time here. July, June, May. Oh, that's a J. May, April, March, February, January. Okay, so that's about 1, 2, 3, 4, 5, 6, 7, 8 months. Now the piece I'm missing is that initial amount, that A. This is what we call our initial amount here. And we have a 0.97 decline, okay, decay, decrease of about 8 months. And then if you just want to work that out on a calculator, okay, that's just simply taking the 364,800,000 and dividing by 0.97. Generally, I like to put this in parentheses, even though I may not need to. It's something I like to do, kind of just keeps things organized. And then it's about 465,000. This is one where you're working back in time. This is where a situation where you're actually going to divide both sides by 978.97 to the 8th. Just trying to get A by itself here. A lot of this has to deal with time, the growth or decay. Here you have another one. She recorded total when she walked. You have the increase. You have the percent. All right? So what you like to do is take the 1 plus or minus. This is an increase, so we're going to go plus the 4% as a decimal. Don't make the mistake of making this 1.4. Don't make the mistake of making this a 0.4 increase. You have the whole. This includes the whole. You're taking what you have and increasing it by 0.4. So you're increasing it by 1.04. And this is after 10 weekly increases. So I have the time there. She had increased her walking time to 89 minutes. So again, this is the idea of having something in the beginning there, or looking for the piece that's in the beginning, given what you have in the end. And then we could take the 89, divide that by the 1.04 to the 10th, and we get 60.12. I believe on your standardized part of this multiple choice, it's just going to say 60. It's going to ask for approximation there.
Can I have that?
Yeah, where they're available. The half-life of a radioactive element takes 50% of its atoms. The half-life of radon is about 3.8 days. You'll see this in any sort of like SAT or standardized testing. This actual piece of information tells you about half-life, but is really not involved in the question. About how many grams of radon will remain after a sample of 16 grams. So would remain, now we're talking a little bit solving for that final amount here. You started with 16 grams, that's your initial amount. Don't make the mistake of saying half-lives is 3.8. There's a decay. This question's really pertinent because atoms actually have a decay. That's the word to use there, 0.5. And then you have after 3 half-lives. That's 16. Oh, that's a negative 0.5. And it happened 3 times. And you end up with a with a value of 2. And it makes sense because basically, I mean, if you just took 16 and divided it in half 3 times, I mean, this is one of those situations where maybe the calculator wasn't totally necessary, but here's your 3 divisions and you end up with 2. Again, this will be available. I'll tape it right up on the wall when we're finished there. Miss Lawrence wants to invest a piece of land that costs about $54,000. I like to make lists. She expects the land to increase by about 5%, so you can put an arrow and say 5% increase. How much would she expect it to be worth after 5 years? After 5 years tells me we're searching for a final amount, given the 54,000. Ooh, a 5% increase would actually be, 1.05. You use the 1 because you want to include the 54,000, right? You're saying this and the 5% increase. So let's rewrite that as it should be, 1.05, and then that's after 5 years. Calculator sure makes this easy. Yeah, so it's about 68. So why do we use 1? Well, think about it. If I want to find a 5% increase of 54,000, right? One thing I could do is I could take 54,000 and multiply it by 0.05 to find out what that 5% is. So 54,000 times 0.05 gives me 2,700. Correct, right? So what I would end up doing is say, okay, I'm going to do 54,000 plus the 2,700, which gives me, I can't do it, but my brain is just, okay, 56,700. Okay, now this only represents 0.05 of the 5,400. This here represents the 100% of it. So if I'm adding to the 5,400 my original amount, the 5%, why not just include 5,400? Why not just include the 100% that I had, which is 57? So if I took 100% and made that a decimal, I would move 2 decimal places, and that'd be 1.0. So I'm including, here's my 1.0, this is my 1.0, and this is adding my 0.05, and put that together, that gives you 1.05. So what this allows you to do is kind of skip that adding step. I don't need to find 5% of 5,400 and then add it to the, I could just include it in my multiplication. Again, this will be taped on the wall for you guys. Fractal. Got to look that up. What a fractal is to teach a student about patterns. The fractal starts with 2 rectangles at stage 0. This is what I would do on any standardized test. I'm just going to start making a table. Here's stage 0, and I'm at 2. The number of rectangles in each of the following stages is 4 times the number. So here's my growth, about 4 times. And then what would happen at stage 11 using exponential equations? So basically, ... you have, or are looking for a result at the 11th stage. And in between that, you've had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You've had 11 stages. So if you're confused by the stages, maybe sometimes making a little table to ensure, okay, is it 10 stages? Is it 11? Where did I start? And so you started with 2 rectangles. It quadrupled and it went up about 11 times in the pattern, which would give me 2 times 4 to the 11th power. Look at just 11 stages multiplying 4 times. Look what a big number that could give you. And imagine if you sat there, there'll be students on an SAT that are sitting there going 2 times 4 equals 8. 8 times 4 is equal to 32. And you're gonna see this whole thing take place, and they're gonna go 32 times 4. Da, 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 da. And then you're gonna see this student who's like got this massive down the column of their page and trying to work out what that is. Where just using just kind of like this exponential function, really, this is a great shortcut when working with SATs.